So hello everyone, my name is Anshul. I'm your host, and today I have with me Abhisek Datta. Abhisek is a cybersecurity expert. I have known Abhisek for last 5 to 6 years, and he's one of those persons who found their calling very early in their life. As far as I know, Abhisek started hacking at the age of 11. And in my interactions with him over the years, I've enjoyed listening to his stories of how famous exploits were carried out. Abhishek is also currently building an open source project called VET. It's a tool to discover open source vulnerabilities in your code base. So welcome to the show, Abhishek, and thank you for joining me. I know I've been pestering you for this conversation for a long time, but thank you for agreeing to do this time.
Yeah, really happy to be here.
Yeah.
And
So
I just want to mention one thing here. I think you kind of really aroused my interest in podcast by sharing all those podcast links. So yeah, really happy to be here.
great. So let's get started. So to begin, Abhishek is also a practitioner of kalaripayattu. So kalari is an Indian martial art. So maybe we can use that fact as the launching pad for our conversation. So Abhishek, I would love to know, have you found any parallels between kalari, martial art, and cybersecurity and hacking?
Yeah, okay. Let me kind of think about it. Okay. So it's not like I did Kalaripayattu for a very long time. I think I did about practice Kalaripayattu about 2 years before COVID. And during COVID, it was mostly online classes, which was like on and off. I was not very regular. And eventually, after COVID, I again continued for almost a year or so. But eventually, I was not able to continue. Even though my wife and daughter, they are like very regular and
Yeah.
they have participated in some, some of the state competitions as well. So
Right.
now, if I have to look back in Kalaripayattu, right, it kind of started with some physical conditioning. Like, say, whoever joins Kalaripayattu now, they will spend probably 6 months just to physically condition their body, right? So maybe these are like building some foundational capability so that they can learn Kalaripayattu.
Right.
Right. So Kalaripayattu is a very established discipline. It has like syllabus. No, I would not say it's very well documented or books are there or anything. It's been probably passed on from generations of teachers or gurus to their students, who in turn become gurus and they pass on, right?
Right.
But what I have learned is that it has established syllabuses called Adavus, right? You start with Adavu 1, Adavu 2, which consists of various physical demonstrations to start with, maybe jumps, kicks, and all these things. And eventually you get into wooden weapons, then you get into some metal weapons, for demonstration purpose and all of that, right? But all of this will happen once the guru will start all of these things once he feels that you have the right foundation. Physically, you are physically conditioned and capable of starting that,
Right.
right? So I have always, now going back to the cybersecurity or hacking side of things, whoever asks me like how do I get started with cybersecurity, I have always given them kind of unconventional advice, right? I have told them start with how computers work, learn that,
Right.
right? Forget, I mean, cybersecurity may seem very exciting, like finding flaws, trying to compromise the system security. But
Right.
unless you really learn how the system works, right, you will always end up trying to reproduce someone else's techniques.
Right.
You will not have the freedom to find something new on your own, right? So, cybersecurity is nothing but finding security flaws in computer systems.
Right.
To do that, you need to know computer systems. So, you need to know programming, you need to know networking. Maybe, I mean, back in the day, people used to know operating systems very well. They used to know how the operating system works, how the kernel works, then the user space, what are the tool chains that make up the application programming layer. what are the common flaws? Like back in the days, there used to be vulnerabilities for applications written in C, C++ related to stack overflow, heap overflow, integer overflow. These were the vulnerability classes in native system software back in the day. It will be very difficult to understand those unless you have a foundational understanding of how computer programs are written, how a compiler transforms, say, a C program into an executable. I mean, you don't need to know exactly how compilers work, although it's great to know, and how an operating system loads and runs a program. Right?
Right.
I would always recommend. But now I think things have changed. Things have become relatively easier. The number of people who were gathering those knowledge and attacking system softwares have probably reduced. Most of the interests have moved on to application security, like related to web applications. A new class of vulnerabilities related to web application like SQL injection, cross-site scripting, and those kind of things. Where it seemed to me, again, this is kind of my opinion, the barrier of entry was much lower compared to the early days of hacking.
Okay.
If someone wants to get into web application security, it seems to me it is much easier these days, where you can become a practitioner by consuming large amount of content that is available today on how to use tools, what are the steps to do in order to find or test for this kind of web application vulnerabilities.
Right.
So, and also there is an economy. By the way, there is an economy. I'm not sure if you're aware. There is an entire economy called bug bounty.
Yes. Uh-huh. Uh-huh.
Yeah, so you get paid for finding flaws in
Correct.
websites and applications and all of that. That is an interesting thing, right? That is like incentivizing people into getting into this field,
Right.
and I think it has worked well. I don't have stats on bug bounty, but I do see a large number of students want to get into this field, not because of the curiosity of how computers work and how to find something, but because of bug bounty.
Right.
So, good or bad, bug bounty has probably contributed to the growth of people getting into this domain.
Right. So
So,
it's like it's a way for aligning the incentive in some way to promote a certain kind of culture. So I see that happening. So
yeah,
in India, UPSC I think is one of the biggest what do you say example of how, in spite of being extremely low probability of somebody getting a seat, right, in UPSC, still the competition is so high because the payoff is so big, right? So you have this
yeah.
system built around it. I was listening to a podcast recently wherein one of the authors proposed a very interesting idea, how to use this idea of similar, designing incentives to drive behavior, wherein, so this year in Bangalore, the turnout for voting was very less, 55%, right? And of course, one of the reasons people were saying that the voting day was on a Friday, it was a long weekend, it became a long weekend for people. So instead of voting, they went out for vacation. And he said then, do one thing randomly. So you declare that in Rajya Sabha, there are few nominated members, right? So out of that, you declare that 6 people. And for that, you don't even have to change the law. You can just nominate saying that randomly we'll pick 6 people who voted as nominated Rajya Sabha members, any 6 people who voted in the country, right? And that itself, for a lot of people, that's a big incentive for them, right? That, what a
Ah,
lottery of becoming a Rajya Sabha member. So that's an interesting.
yeah.
As you said, in India, usually the incentives, it's actually sad also that people are, instead of being curious about how computers work, they are more interested in that bug bounty reward program. And probably that is also driving the even in the software programming field, that's driving the culture of, instead of learning how to program well, and instead of trying to figure out, even the whole idea of contributing to the open source is not inherently that people want to contribute, they just want a resume building practice, right? So there are influencers in the social media who are teaching people how to just do a simple commit in the open source project, which is creating havoc, like you shared with me that day, right? If somebody was showing, some influencer was showing how to do a commit in Express.js library, and he was just showing us as an example, and millions of people who were following, they just went and opened random junk pull request against Express.js library, exactly word to word, same library, they were just doing it, right?
Yeah, the maintainers had a hard time closing all those pull requests.
Right, right, right.
Yeah, yeah. But
Yeah.
I think when coming to that bug bounty thing, right? Personally, I would like to kind of think from the other perspective as well. Like personally, I when I started with security, the people around me or the people I looked up to, they were driven by how systems work or finding flaw, the excitement of doing something which a system does not allow. Right?
Right,
A system does not allow to gain access without the necessary credentials.
right, right.
Right? That is the contract of a system. The
Correct.
excitement of trying to do something that allows you to bypass that
Yes,
was really, really, I would say a dopamine rush for
correct.
all the people there before the Facebook era or the social media era.
Right.
Now, probably something else gives that rush to the people. Right? I, 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 I'm not sure if that's bad or good because if I remember correctly, probably Linus Torvalds only Linus Torvalds only said this, that given enough eyeballs, all bugs are shallow.
Okay,
Like if enough people is looking into it, you will end up finding all the bugs, right?
correct.
Maybe he meant it in such a way. When I look at the bug bounty program, it's like kind of like the UPSC only,
Right.
right? A large number of people are getting into cybersecurity because of the hope of making some money through the bug bounty program, which is open to everyone.
Right.
And obviously, not everyone is successful.
Right.
Maybe, right? But a lot of people are trying. Say, even if, say, among all these people, even if, say, 2%, 3% actually develops themselves, learns what is required, and grows in skill, the cybersecurity workforce will significantly increase, right? And which is, I think, I again, I don't have a stat, but I have seen that the demand for cybersecurity workforce is still quite high. It's not enough cybersecurity workforce is there,
Okay.
right? So maybe the bug bounty program has created incentive structure for more people to get into cybersecurity, which will eventually lead to more secure general systems,
Right.
right? So maybe it's a good thing that has happened.
I think that's yeah. So it's like, even if it inspire, even if it drives thousands of people after bug bounty, maybe out of those thousands, a handful of people will actually, in the process of winning, trying for the bug bounty, they will figure out that, oh, this is something. There is the reward is something bigger than bug bounty. That, what you call, that satisfaction of finding
Yeah,
within the system, that inherent, what do you say, intrinsic reward of cracking a system. When that becomes the
yeah,
case, at least you might end up getting a handful of internally motivated security experts or cybersecurity enthusiasts. So
yeah.
physical side of it.
But unfortunately now I mean again there is a full industry which is into large scale hacking,
Right.
which is supported by the nation states.
Correct. Correct.
I I do see some like very recently there is a very famous security company called Qualys,
Mhm.
right?
Okay.
Their research team recently published a security vulnerability that they found in OpenSSH.
Right.
It was great, like very, very technically in depth, very, very innovative research, right? And I do see Google has a team called Project Zero,
Mhm.
who is responsible for doing vulnerability research, security research on various technologies that which is critical for the internet infrastructure. They don't have a very defined scope. They look into Android applications or the Android core operating OS, open source libraries, open source software. I see their research is also very technically deep. and very, very innovative, or something that requires very high skills. Back in the day, I would say a lot of people used to, maybe, back in the day means maybe around early 2000 or even mid 2000, a lot of security research used to publish this kind of content. They used to write very detailed technical document on research that they have done or vulnerabilities that they have found. That number has significantly reduced. Very few handful of people these days publish really deep research on the offensive security side of things, right? Maybe that is because a lot of countries kind of employ people who are capable of finding vulnerabilities in critical infrastructure, like say, power grids or operating systems like say Linux or Windows, which are being run on critical infrastructure, right? And because of this economic model where states are actively using cybersecurity as an offensive capability,
Right.
a lot of high-skilled researchers have probably moved on to that side of business, and they have stopped kind of publishing that.
Right.
So bounty is probably the, I would say, the democratization or the large-scale uh, uh, reward program for finding vulnerabilities, but these are mostly shallow bugs. If you look at the kind of attacks that are used to compromise very high value target at a nation state level, they are very, very complex and highly innovative research, requires very high skills.
Right. Yeah. So since you mentioned this idea of nation states driving this whole sophisticated attacks, so that brings us to the scaffolding for this conversation, the XZ vulnerability, right?
Yeah.
I wanted to use that as a backdrop for our conversation today. So maybe if you could just give an overview of what happened in that XZ vulnerability. I mean, if you want to explain it to a layman, somebody who understands software but doesn't know the internals of it, and yeah, so maybe if you could spend few minutes explaining that, and then we'll dig into it to find certain patterns and the connection of cybersecurity, open source community. Yeah.
Sure. Firstly, I think I would probably just quickly explain the two things: vulnerability and malware. Okay. I am not sure why the industry is calling XZ a vulnerability, even though there is a vulnerability ID is attached to it. Vulnerabilities is like a flaw. I don't have the intention of causing something malicious. Like I wrote a software and someone found a flaw in that software, that the code that I wrote, and they are making my program do something unintended, which has a security impact. And that is a vulnerability. But in case of XZ, it was a malicious intent,
Right.
right? So what happened was, I think a group of developers. I think it's not just a single person, even though I think the name Jia Tan is quite popular now. But it was a group, or I would say a malicious actor group. What they did, they engaged with the XZ project, right? And they were kind of putting pressure on the original maintainer that you are not fixing bugs and you're not making releases. You need to take up because this is a critical project. A lot of other software depends on it. So they put a lot of pressure on the original maintainer using what is called the sock puppet accounts. Like, they are not real users, but this attacker group posed as users of the XZ software and created some pressure on the original maintainer.
Right.
Then there is this user who goes by the name of GitHub user, goes by the name of GFM. He contributed to that project, I think, for over 6 months or so. I think maybe more than 6 months. They contributed to the project, actually helped the original maintainer. And eventually, the original maintainer, I think he mentioned that he has some personal issues, going through a lot of stress, and he's not able to maintain. So he made this GFM guy a co-maintainer. Co-maintainer means you have the right to make a release, right? And what this Japan guy did over a period of time, he introduced some malicious payload, I would say, as test data into the repository,
Okay.
right? Uh, and not really code, some malicious payload. When he did that, it actually did not have any impact. And eventually, what this Japan did, I think in version 5.6 or something like that, he made a release where the release artifact, the release tarball, had a malicious script which will inject those previously committed payloads into the liblzma, the library which was built on system. So it was pretty much planned over a period of time. It's not like a sudden one-off impulsive activity. It was planned for maybe 6 months, maybe a year, or even more. Right. So they introduced a backdoor in liblzma, which is used by a lot of other critical software. And eventually, it was found that one of the most critical software on the internet today, OpenSSH, right, was also impacted because some OpenSSH by default did not depend on liblzma. Maybe we can talk about OpenSSH and their attack surface reduction. But OpenSSH directly did not use liblzma, but some of the distributions, like in this case, what is known about the Debian project, right? They patched OpenSSH server to have some integration with another software called systemd.
Hmm.
And systemd in turn, libsystemd, in turn depended on this liblzma.
Okay.
So in Debian systems, the OpenSSH server ended up loading the liblzma library, even though it did not use it at all. It did not require it. But
Right.
because OpenSSH server dependent or was depending on libsystemd, and libsystemd in turn depends on liblzma,
Hmm.
the Linux kernel will load all these libraries into the address space of SSHD. And once the library is loaded, it kind of hooked. I say, I'll use maybe I'll explain what is hooking. It hooked a function related to cryptographic key decryption within the address space, within the memory of SSH server, right? And that function is called as part of the authentication process.
Okay.
So when SSH server called that function, instead of invoking the code, its original code, it ended up invoking some malicious code and liblzma.
Right.
And it would do a bunch of checking. I mean, just to avoid detection, it would check if it is SSHD, if it's located in a certain way, if it's running in a specific architecture, and it would just bypass the authentication if the user who was connecting to SSHD was using a particular key.
Hmm. Ah,
Yeah, so that would, if this attack would have been successful at scale, it would give the attackers access to all the OpenSSH servers without any credentials,
right.
which loaded this malicious version of liblzma.
Okay.
Yeah, it was pretty bad, but somehow luckily it was contained.
Right. So what struck me about this whole story was one, of course, as you said, definitely it was not one actor or a group of actors, single, and I mean a group of motivated actors. It was actually a very well planned nation state level of attack because the time scale involved, there maybe the resources involved were indicating in that direction, and the social engineering involved, as you said, right? It was not just a one, guy like Jiatan doing all the stuff. It was his sock puppets trying to put pressure on. So first of all, they selected a library like XZ, which was primarily maintained by a single guy, right? And you also gave an example of this guy Daniel Stenberg, right, who's the maintainer of curl. In his blog he writes about
Mm.
feels lonely sometimes, answering so he's the only guy who maintains curl, and curl is today possibly used by more than 1 billion users all over the world.
It's
And
there in everywhere. It's there everywhere. Curl is there everywhere.
he's the only guy who's maintaining it, and it's just a thankless job. It's just that right now he's employed with Firefox, and Firefox generously and gives him space and time to work on curl actively, but still at the end of the day he's the only guy looking after it. And something similar probably happened with XZ maintainer, wherein he was too stressed out about too many requests coming in, although it said that XZ as a from a software point of view, it was done way back into 2010. But just to look after the bugs opening up and maintenance requests which are coming to him, he felt maybe overpressured. And the moment a sophisticated group of sock puppets, pushed him across, saying that you are not maintaining it properly, putting him psychological pressure on him. And then one of those guys became Gia Dan, and he came as a rescuer. And, it's like a
Yeah.
good cop, bad cop strategy. And then he came and he won the trust of the maintainer, and that's how he got in the whole thing. So
Yeah,
it,
I just want to mention two things here. Software, even if a software is complete, it always requires maintenance. That's the problem with software because the underlying platform is changing. Like, say, for example, as you mentioned, in 2010, XE was mostly done, right? Maybe even if they don't have any bugs or any feature, but they have to keep on maintaining it to make it work with newer version of libc, newer version of operating systems, support different operating systems, different system configuration. It's a lot of work even if there is nothing, right? Still it's a lot of work. They have to package, they have to manage it. And the second part, there is a terminology just want to mention here. This nation state actors are very persistent,
right,
right? uh, they have targets. They don't attack randomly, right? Like, say, most cyber criminals on the internet. They have specific targets. And the industry calls these groups APT groups, Advanced Persistent Threats.
advanced persistent threats. Okay,
Yeah, APT. Yeah.
okay,
The reason being, they mostly consist of individuals who are pretty high skilled and they are incentivized to spend as much time required to go against specific targets, no matter how hard the target is.
right.
Yeah, so generally, I mean, very large scale, very serious attacks have happened because of this epidemic groups.
In fact, I was a few days back, I read somewhere that almost 97% of commercial software contains open source code, some of which might not be regularly maintained, something like XZ. And since 2019, um, they probably did a survey across the countries, and they found that 42% increase in the high risk vulnerability, precisely attributing to this fact, right? So this I see. So in this XZ story, this is the weak link, right? The weak link being that one very critical library, which was vulnerable. So as you said, it was not really a vulnerability; it was malicious intent which deliberately introduced the vulnerability or maybe a malware inside it. But the vulnerability of the whole system was that it was a single library maintained by a overstressed maintainer, and then he was vulnerable to this kind of social engineering kind of attack, right? So
Yeah. Yeah, maybe this is the tragedy of the commons, right? Tragedy of commons situation that everyone has taken this foundational software like LC or say GZIP or say compilers like GCC or a Linux operating system has so taken them for granted that I mean, like, say, when I build something, I would just assume that yeah, base systems will work. I will not go buy it or pay for it. I would just assume that it is there. And this is what is being exploited in these times in this category of attacks, what is called software supply chain attacks, which will definitely grow over time because this is, as you mentioned, right, this is a massive issue.
right, right. So this was the I mean from the weak point of view. But then again, at the same time, the whole strength of open source software system is what actually, in a way, was the reason why this vulnerability or this malicious attack was caught in very early, right? And
Yes, transparency. I would say the transparency that open source software brings.
right. Right, and it was visible to so many other people maintaining it, and also um, the person who caught it, uh, he was being an open source contributor. He was motivated enough, and he was sharp enough and intelligent enough, and he cared too much that a few milliseconds of difference he could notice, and that led him to what's going wrong. Otherwise, it's And it's like when you have so many people, so many, as you said, transparency plus so many eyeballs, as you said, Linus Torvalds quote, right? Too many eyeballs, all the bugs are shallow. And this is
Yeah,
right. There was like too many eyeballs, and some of those eyeballs were sharp enough to, and they cared enough to see that there's something wrong with this, what's going on, right? And it's
yeah,
that was the reason, and this systematic attribute of open source community, which is the reason why it was caught, right? So that is a good,
yeah. One thing to note here, it happened. Most of the senior engineers, in my experience, are like performance nuts,
right?
right? Once you go a certain beyond a certain level, you just want to optimize. Even if everything is working, you will see, "Hey, what is this? Why is this like 10, it's taking like 20 microseconds more. Let me figure out, right?" And that is exactly what happened because of in the backdoor system, there were some CPU spikes and there was some latency increase, which I mean, which the person actually investigated because he was not okay that suddenly what happened, my system became slow, and that was the trigger that how such a massive scale issue was averted.
And the guy who actually found it, he was a Microsoft developer working on a Postgres, right?
Yeah, yeah.
He was trying to maybe optimize something on the Postgres, and then he traced it back, saying that this is not the Postgres problem, this is this problem, and then he found it, right?
Yeah, maybe something like that.
A senior guy, right? For him, so for somebody who is very new, a fresher, or somebody who's a very less experienced, he would say 10 microseconds, 10 nanoseconds, how does it matter? But then a senior guy who's actually maintaining systems at a large scale, and this again ties back to the point that day you mentioned about things which work at one scale, they fail to work at different scale, right? So maybe
Yeah,
they have that senior guy has that understanding that, what you're looking at is 10 nanoseconds. It's not 10 nanoseconds, it is 10 nanoseconds multiplied by 10 million, and then it will blow up. So that's
yeah, yeah,
about performance issues, maybe.
yeah. By the way, I used the wrong unit. It should be a millisecond. Microsecond is too less. I mean, generally latencies and all are measured in milliseconds.
Right, right. So yeah. So again, I I want you to also just share a little bit about your experience fixing the Log4j vulnerability.
Oh, okay. Yeah. So Log4j was interesting incident. I still remember that on that day, right, I took my mother to this Apollo hospital for some routine checks.
Okay.
And around, I think, 9 o'clock or so, someone posted in Slack about a Log4j vulnerability in the internal Slack of the company that I was working for. Right?
Uh-huh.
And then I think around 10 o'clock, I got the call from the CTO of the company
Okay.
that, hey, what is this Log4j vulnerability? It's being exploited at various places. We
Uh,
have to fix it immediately. So luckily, my work at hospital was done. So immediately I came back and we started, the security team and the platform engineering team started exploring the Log4j issue. I mean, we were caught off guard. We knew that we are using Log4j, but we did not know like which version is vulnerable. What is the vulnerability? How severe it is? Like, can we fix it next week or can we have to fix it now? So eventually, it turned out that it's a very critical vulnerability. Maybe we were vulnerable. We did not know that we are actually vulnerable or not. Maybe we were vulnerable, right? But we given the value of the platform, we could not take that risk, so we had to go ahead and fix it. Now, updating to the fixed version of Log4j within an hour was risky for us because we had to check because logs are important for us. The logs are used to detect issues in production, right? So we felt that it would not be possible for us to move to a patched version of Log4j and mitigate the issue in production right now.
hmm.
So instead, what we did, we looked into what was the fix, and we also saw that someone has blogged about some mitigation where a specific class, I think JNDI loader in Log4j, was used for all the real life exploitation. Even though the root cause of the vulnerability was something else, that JNDI loader class was used by attackers to execute code in a vulnerable application using vulnerable version of Log4j.
Okay.
So what we did was we wrote a Java class with the same name, which would just throw an exception when that function inside that class would be called,
Okay.
right? And we just put that class at a higher priority in the Java's class load path, so that our class is loaded by log4j instead of its original code. And the idea was that it will prevent exploitation because that JNDI loader functionality will not be there. And secondly, because it will throw an exception which will get logged, we will know if our systems are being exploited in the wild, right?
Right.
So that was the patch which was rolled out, and I think it was rolled out pretty quickly. We were able to safeguard our most important applications, and then but for the team, for the larger team, it was I think almost 48 hours of auditing. So mostly we did not slept.
Mhm.
We had to figure out all the systems that may be vulnerable. That was itself is a challenge. I was talking about the main system, right? There were a lot of other internal systems, a lot of microservices. So that itself was a challenge. In the same week of Log4j, I think three vulnerabilities came up successively. Like when the patch was rolled out, someone found another way to bypass the patch.
Yes.
Then again, the another patch came out fixing that issue. Then again, someone found a way to bypass the patch. So it was an entire week of trying to safeguard Log4j. So yeah, it was an interesting experience.
So when you were explaining this to me last time, you also mentioned something about SBOM.
Yes. So SBOM is software bill of materials, which is basically an inventory of all software components which is used to build an application. Yeah. So say no matter what application I am writing today, say I'm writing a Hello World application, right?
Right.
It would be compiled by some compiler. It would use, even if I'm not using any libraries, it would still use the system libraries, right? Which will probably have printf if I'm using C or some, in case of Java, it will use some standard libraries. Any significant application today is written heavily depending on open source libraries.
Right.
I'm not going to re-implement everything which that exists in open
Correct.
source. I'm not going to write a database adapter. I'm not going to write a HTTP request library, or all of this I will use from open source. Right? Now, when I built a software, it's not just my code. It is a lot of open source code or third-party code. Right? The idea of SBOM is to build a machine readable inventory of all the third-party code, as well as my own components, my own libraries, which constitutes a application artifact that I am delivering. Delivering means giving it to someone or running it in my environment. Right?
Right.
This is very important. In our Log4j incident, if we had SBOM for all of our applications, that means that we would know that for application one, these are all the libraries. And
Right.
for each of these libraries, these are all the libraries which these libraries depend on. So I would know all the components which exist in application one.
Right.
Then similarly for all other applications. One of the challenges we faced responding to the Log4j incident was to find out among, say, X number of applications that we operate, whether internal or external facing, which are the applications that is vulnerable, or which are the application which is using a vulnerable version of Log4j, right? Because we have to prioritize. We can't fix, say, 100 application right now.
Right.
If we had SBOM, we would just search for, say, vulnerable versions of Log4j and then backtrack and find out all the application which is using a vulnerable version of Log4j. It would have been very easy for us to find out which all applications are affected, and then we can in turn prioritize, like maybe external facing applications needs to be prioritized first, then the internal.
Right.
So this was missing that time, but I think we prioritize building SBOM for all our applications. And eventually, again, using open source tools, we were able to build the SBOMs and build a very nice dashboard where you can go and see what all things are there for an application, as well as find out that for a given library, which all applications are using
Right.
this library. So yeah.
One more thing which just occurred to me, going back to the incident, right? One of the recommendation for avoiding those kind of instances in the future was, of course, as you said, the hackers are always one step ahead because the defenders are always looking at what has already been exploited, and they are only, but the hacker is looking for a new opening. So, but to avoid the same thing, the GR10 incident again was that, maintain some initiative to maintain a list of all such libraries which fall in the category of XZ, which are like very crucial but maintained by very small community or maybe a one or two single maintainers who are vulnerable to this kind of social engineering kind of attack. And then you mentioned that somebody is already doing it, OpenSSF, right?
Yeah,
So,
yeah.
yeah. So if you could just add some more to it, what exactly is OpenSSF? How does it do it?
Yeah, yeah. So I think the risk of single maintainer projects, open source projects, or open source projects which is maintained by very small number of people, one or two people, right, is now well established.
Right.
Because they, even if they don't turn malicious, they may get compromised also. It's not like in case of XC it was a malicious incident, but it may happen that one of the maintainers laptop gets compromised and an attacker uses that machine or that credential to introduce a malware. That can also happen.
Right.
So the industry as a whole now understands this risk.
Right.
They understand that open source is very, very crucial. Open source is like the foundation of building modern software. You cannot say that open source is bad or open source is risky, so you will not use open source. That is not possible anymore. So what needs to be done is that you need to secure the open source ecosystem, ideally at par to the security practices followed in a fairly matured enterprise, right? Now, that is a very big, very difficult problem statement because you have control over all the software that you produce within your organization.
Right.
And over a period of time, you can enforce certain security standards. How do you enforce such security standards for software written by people across the world using their free time and most of the time voluntarily? You
Right.
can't tell this developer who is working building something voluntarily that you have to use this tool, use this security scanning tool. It will tell you hundreds of vulnerabilities. By tomorrow you have to fix all of that. He will say get lost, man. Okay. So this is a massive problem statement which OpenSSF, the Open Source Security Foundation, which is supported by I think Google and various other large enterprises like Microsoft and a few other companies. OpenSSF is under the management of Linux Foundation, and their goal is to build the standards, the best practices, and the toolings required to secure the open source ecosystem.
Okay.
They are not going to take over the open source project or anything, but they are going to actively engage with the open source developers, provide them the necessary guidance. Like I think I just saw they have a free course available for secure software development, primarily aimed for open source developers. Right? So they will engage with the open source community, give them the required tooling and all these things, so that overall the open source ecosystem adopts more secure practices.
Right.
They will also identify the most critical projects like XZ or curl, or there are a bunch of other projects out there in various ecosystem. I think they also offer funding or support in terms of developer support to ensure that these open source projects have the necessary support to keep on building what they're building in a more secure way.
Okay. Yeah, so this imagine if this XZ thing would have happened to a closed source software, right? Then I mean there was very less chance that somebody would have caught it. Imagine somebody got root access to Apple OS, right?
Maybe
So
it's happening. Maybe it's happening, and it has happened in the past. It has
right,
happened in the past.
right.
With one very significant incident is the SolarWinds
Okay,
hack.
okay. What is that?
So yeah, SolarWinds hack was significant because U.S. government's executive branches were compromised.
Okay,
Microsoft was compromised, I think, and various other significant organizations, including security companies
Hmm.
who work on malware analysis, they were also compromised.
Right. Right.
So SolarWinds is a, I think, software company who has been building software for network management, network monitoring, and a lot of IT operations related software.
Hmm.
And their software is used in a lot of government organizations and very large enterprises.
Right.
What happened was their build infrastructure was compromised
Right.
by attackers,
Hmm.
and the attackers introduced malwares in updates to SolarWinds, I think Orion software package or something like that, which is used for network monitoring, right?
Okay.
So they introduced a malware there, and through that update, that malware got deployed across a lot of organizations.
Okay.
So it has actually happened, and it was not detected like exe that one fine day some developer managed to detect it. It was there for a long time.
Right.
And I mean, even researchers, even today, I don't think they can confidently say that when that malware was introduced and how long it was there. People are still guessing.
Right. Did they?
So it has happened in the past.
Yeah. And this so this point that let's say so we said libraries which are maintained by a single maintainer, maybe he would be at the receiving end of social engineering attack. But imagine if the maintainer himself turns rug, like you gave the example in case of the Russia Ukraine war. A lot of open source maintainers who supported Ukraine, they deliberately introduced vulnerability or whatever, the malicious code inside their own codes because they thought using that they can actually support Ukraine in some way. And that goes
Yeah,
to the whole philosophy of an open source. Or just because you are a maintainer, you have founded the project doesn't give you the right to turn it into a malicious code. So
yeah, yeah.
yeah, so that way the whole idea of democracy, and I think it connects very well to outside the world outside software also, right? The way you run a country, the way you run a community, the way you run a government. This whole general idea about having too much trust on a single actor, hoping that he is a saint or he is good at heart. Just this is a fallacy that he cannot turn rug, right? He can. I mean, it's a human nature, right? You don't know uh, at what point he can actually his mind can change, right? So your system should be in a designed in a way that even if the founder of a open source community, a single maintainer, he should also be checked. His rights should be. So like you mentioned the idea of 4I code review, right? So uh, at least 3 to 4 maintainers and diverse maintainers,
Mm.
not that all 4 of them are friends sitting in the same place and maintaining a code. So yeah, yeah.
I
So
think a very good point. Diversity is very important here.
right. In fact, this mental model called wisdom of crowds, I think, which very well connects with the idea of open source community, right? Because in the open source community, when a software is being built, not just from the point of vulnerability also, but also from the point of view of how strong your software is, what all features it addresses to, the more diverse people contribute to it, right? The more the richness of the software will increase. And also that same diversity of people will also create the right checks and balances and guardrails to ensure that it doesn't do something which is what it's not supposed to do. So,
Yeah,
so the wisdom of crowd is that idea which says that you need to have that
yeah.
in a community to ensure that the outcome of the collective outcome of the thinking or the work is directionally in the right direction. So,
True. Just one thing to add here. I think in case of open source software, right? All open source project mostly start with a single maintainer only because unless it is started by organization like Mozilla or Apache who has the necessary funds and they know the problem to solve, it's mostly started by a single maintainer. Even if I build a very good software, high quality and very useful software, it is my opinion that it is high quality and useful. Unless there is a community around it, it's the users of open source software that makes a software important,
right,
right? And when there are enough users, when the software becomes more impactful because a lot of people are using it, that is definitely the time when more people need to be involved. But in my experience, most of the maintainers, most of the creators of open source software, they end up creating a community of users and community of maintainers for the software.
Right.
If as a creator of an open source software, if I am not able to build a community of maintainers or users, mostly my software project will fail. It will be there, but not many people will use it. It will not be that impactful, right? So maybe it's a natural process for most of the open source project that as it grows in usage and importance, organically a set of maintainers will come in. Because think from this perspective, it's like a self-balancing process. I build something and a lot of people is using it, only then it will become useful.
Correct.
Because a lot of people is using it, there will be a diverse requirement,
Right.
right, which I as the only maintainer may not be interested in. Say someone, you tell me that this is required, I will say this is probably not that important.
Right.
But if that person is also an engineer and agrees to contribute that feature which they need, then I would be perfectly fine as long as it is not breaking the existing functionality, right?
Correct.
So that is how I think open source ecosystem is like a self-evolving entity where people contribute out of their own requirement, out of their own needs or incentives, right? And that is how software grows and more people get involved and it becomes, mature. Just that there are like example of curl. I don't know why so many people uses curl, but I mean, personally, I have never thought of contributing to curl because it has everything that I need. I
Right.
don't see I need something and it's not there.
Right. Right. So that's why, again, a lot of popular open source softwares, which are widely used, of course, things like curl and an exception, but and indirectly, if you say curl is also indirectly being supported by Firefox because the maintainer of the curl is indirectly being supported by his employer Firefox, right? But still, there are a lot of software projects, open source projects, which are where the roadmap of that software project is dictated by the private industry who are promoting supporting that open source software. Although to say that it is open source software, but they are actually being the resources being deployed for to keep that open source software active and have an active roadmap is being driven by a lot of profit making software companies. So
Yes.
how do you see that? I mean, is that in some way it is good, but it also in some other way we don't really have that fundamental ethos of a software, open source software, that it should be supported by community, individual actors who are not necessarily driven by a profit motive, right? It's just that intrinsically interested in developing that software. That I see some conflict there.
Okay. I don't think so because again, as I said, open source has a natural way of evolving. Because I'll tell you, see, to avoid tragedy of common situation where no one maintains or no one cares for common piece of software, which a lot of people uses, there has to be some incentive model, right? And an organization supporting a set of software will also need some incentive, right? Why will an organization blindly pay money to the developers or hire the developers on their payroll just for the that using that software, right? So both sides need to have some incentive so that both of them drive the open source project into a direction which may be good for the larger community, right? So I think it is perfectly fine for companies who are sponsoring or funding the project to have the maintainers of the project prioritize feature which is useful for them,
Correct.
right? They need. Now, if that project is not useful for the larger community, anyway, the open source project will die because it will be used by a very small set of people, maybe the company. Right? But if it is used by a very larger set of community, there will be developers who will be contributing other features which the larger community needs.
Right.
And at some point, the beauty of open source is this: at some point, say the company which is funding the open source project suddenly decides that we will stop accepting community contribution. This is the direction we will go. We will change the license where you cannot use it for commercial purpose anymore, right? Which has happened to a very popular software called Terraform.
Okay.
Okay. The community always have the ability to fork the project. That is the benefit of open source.
Right.
You take the open source software till a point where the license is not changed or the direction is not drastically changed. You take that piece of software and you maintain it as a community project.
Right.
Like Terraform is the most popular software related to infrastructure as code. Like you write code to build your cloud infrastructure and all of that.
Right.
Now, because of some reason, I think the company who was building that software, HashiCorp, they changed their licensing terms or they have something. So the community forked and created something called Open Tofu.
Okay.
Okay, so that is like Terraform compatible tool, which works exactly like if I can switch from Terraform to Open Tofu.
Okay.
So that is the thing of open source. Like if a project is impactful enough, that means there are enough users and developers who are using it, and they can like take that and maintain it on their own, and
Right.
something new will come out of it.
Yeah, yeah. I also remember a similar software called Activity, which is a business process management software, BPM, and it was being driven by IBM. And at some point, the maintainers of the project felt that it was not going in the direction they wanted to go, so they forked it and they called it Flowable.
Mm.
And at some point, I was actually evaluating different BPM and softwares, and for some time I got confused that what is this Activity and what is this Flowable and what is the difference. Then slowly
Mm.
realized that the similar story had transpired there, that the maintainers actually forked it. So
Yeah, you will see that there are a lot of examples like that. And in many cases, people rewrite the entire software also. Because, see, for a senior developer, writing code is not that big deal.
right,
Their mind just gets into writing code.
right,
But what is that software? What does it do? What are the features? What are the use cases? Who are the features for? How the users use it? These things, these mental models or this information requires a lot of time to evolve.
right,
So, say for a software X, which is being used by the community for a long period of time, just by knowing what all features that software has is enough to rebuild something from scratch, maybe in a better, more maintainable way.
right. Great. So the last point I wanted to bring in this discussion was about using this idea of open source and the learnings of open source community, the philosophy of open source community, and seeing if how this can be used in context of tech policy, right? So, for example, one of my good friends, Soham Das, he's written a very good, recently he's written a blog on EVM hacking. And he proposed a few ideas about how, so initially in 2010, when some researchers pointed out that there is some vulnerability in EVM. So first of all, they were kind of ignored. They were probably troubled also by state. And one of the researchers was also jailed for some time for pointing out this vulnerability in EVM. And after that, it has mostly been a defensive. So the government has been on the back foot saying that no, there is no, prove it that there is some vulnerability. There is no vulnerability. They would even, I heard that they, arrange a hackathon and challenged people for different political parties that send your agents and show it to us that it can be hacked. Now that is what is happening here is now even if somebody knows that there is a vulnerability, he would be too scared to go and prove it, right? Because he's seen that people can be jailed for it. So one of the ideas was that this my friend proposed in his blog was that you should actually open source the EVM software, right? And then let this whole what happened in case of XZ malicious attack or vulnerability, the same thing, the same power of open source community you can actually leverage on to prove it to the people in India and outside the world also that EVM is hack proof, or even if there is some vulnerability, it will be quickly found and plugged. So EVM being created by taxpayers' money. So this is philosophy of public money, public goods, right? So if you create a public software using taxpayers' money, that software should be a public good. That software should be open source. That should not be behind the closed doors. So extending this idea to GDP, right? So I was listening to an economist. He was saying that GDP today, it's like the way you calculate GDP, it's like a black box, right? There are some certain government agencies which will come out with a GDP number. And again, World Economic Forum or the international agencies will have their own way of pinning down a number for the GDP, but nobody knows. And some will say then on the GDP, if you want to base some calculations, you would probably use one number, one entity will use one number, another entity will use another number. Now, what if you could actually open source the formula, the methodology used for calculating the GDP, and then let it be open to criticism, let it be open to people who want to challenge the methodology, or they want to come up with a better idea. That way you can actually improve upon it a lot, right? So have you thought about these things?
Yeah. I mean, I have some opinion about it, but I don't think I have put a lot of thought. So there are two points that I observed from your question. One is about vulnerabilities, like penalizing people for reporting vulnerabilities, right? That is like hitting yourself with an axe, hitting your leg with an axe. Okay? It has not worked.
Okay.
Responsible disclosure is the best policy, because if you penalize people for reporting vulnerabilities, you have to think that why is someone reporting the vulnerability to you? Is it to cause you a harm, or is it beneficial for you that you know that there is a flaw and you fix it? Maybe the perception, like if you care about your self-image, or if you want to portray yourself that you can't make mistake, then yeah, it may be a small this thing on your self-image, right? But imagine what will happen if attacker with malicious intent finds the same vulnerability, right? And they will definitely find. It has been seen in the past that they will definitely find.
Right.
The malicious actor will actually exploit the vulnerability to do something which is not intended to do.
Right.
And you will not get to know.
Right.
Right. So it's a very common sense. Like, what is beneficial? That someone comes and tell you your system has a flaw. You take this and consider that I have, mitigated or closed the hole in my system, or it's okay for me to say, sit and be, what is that? What is the word? I forgot the word. That being ignorant of flaw. I don't know if anyone is exploiting the system. It's safe as long as I don't know anything is happening.
Right.
Right?
Ignorance is
That
bliss.
is the ignorance is bliss. Exactly. If you want to be in ignorance in this mode, then it's fine. If that is not what you want, then responsible disclosure is definitely the way to go. But you need to have a proper policy for it, that you publish that anyone who wants to report a security issue in your applications, in your system, right? How should they do it? What are the steps to do it? Which email address they should mail? What all information they should provide? And you should definitely encourage that, and if possible, incentivize that. Like most large organization offers you a reward for reporting vulnerabilities to them. Now it has become through bug bounty, but even before the bug bounty era, Google, Microsoft, Apple, everyone used to reward researchers if you report security vulnerabilities, because it's most obvious to them. If you don't encourage that, malicious actors will find the same flaw and they will be exploiting it, not like reporting it to you. So it's better that you get to know about them from people who want to participate in responsible disclosure. Now, the second part about open sourcing any software or any system built on public money, right? I mean, top of the mind, it seems like a very, very rational choice, right? That if you open source software built from, based on public money, then anyway, because the state or whatever government, I don't know if they are supposed to be for profit. If there is a concept of intellectual property in software built by the state, I don't know if anything like that is there or not. If there is a concept of intellectual property, maybe that is a reason not to open source. But if there is no concept of intellectual property or no concept of profitability of software built for the state, then definitely open source is the way to go, because it will provide the necessary transparency and as well as encourage community to support it, right? Unless the software is built in such a bad way and the software is so horrible that you cannot make it open source.
Okay. Or maybe for example, in EVM case, right? Even let's say they make it open source, But there is no other case where somebody else would be using it, because nobody else would need EVM software for anything, right? So XZ was a library which was used across the industry for a lot of things, right? But who would actually, unless except enthusiasts who just want to have a look at the code, right? But
No,
still,
I mean, XZ project can also claim that this compression algorithm is our intellectual property. I will give you binary version. I will not give you the source code. I will build it for all this different architecture and give you the binary version. Just like, I mean, enterprise software is distributed, right, in binary form, right? So open sourcing has its own benefits. Say, for example, in the EVM case, if the design of the overall system, not just the software, maybe the hardware is open source, then it would have been easier for the the larger researcher community to evaluate the system and then share what are the potential flaws with the makers of the EVM, which would allow them to fix that, right? Anyway, I mean, the EVM is probably owned by some ministry. Like I think I don't know who builds the EVM. They will be maintaining the system, right? So having the information publicly available, it's like free input for them. Like they are getting, someone is auditing the system and reporting them about potential issues or maybe even improvements for free,
right,
right? Unless there are known holes,
right,
which people do not want others to see.
right,
Many times, I think a lot of enterprise software builds so-called interface for LEA, law enforcement agencies, right? Those are like intentional backdoors into the system.
right,
So that if something like that is there, then that is a reason why you would not want to make it open source.
right. Great, great. I think we are already overshot our time reserved for this conversation. So, but I had a big list of things that I wanted to, discuss with you. So maybe we'll catch up some other time. We will do another version of this. But thank you so
Sure,
much
sounds
for
good.
joining me today. It was a very rich conversation. A lot of new things for me to learn and discuss with you. I
Thank you.
I'll hope I'll catch up with you again. And I'll put the, so do you want to, in short, also tell our listeners and viewers about the open source project that you are building with, maybe a few lines about it?
Yeah, sure. So I built an open source tool called VET. It's a tool that will allow you, as the name says, vet other open source packages like open source libraries before you use. Like as we discussed, the open source has some risks, right? It has a risk of vulnerability, malware, and all these things. My open source project VET allows you to, establish a guardrail, maybe define a safe open source usage policy for your organization, write those, codify those policy, and ensure that whenever your engineering team is using or adding a new open source library or a new version of library, my tool can automatically vet it and tell you if you are introducing any new risk or if there is any vulnerability or malware in those libraries. Yeah, so it will enable your engineering team to improve the way you consume open source software from a security perspective.
I think it's already running into millions of downloads. Last time you shared some statistics with me.
I have a backend. It has about, I think, 2.5 million API calls are there. The
Okay.
backend is used to serve data. I mean, public data only, just that my backend serves it with proper caching and everything. Metadata and enrichment data related to open source package. Say, for example, the tool by scanning your source code, it will identify you are using a library X,
Okay.
right? But for the tool to make any decision whether the library X is safe or not, it needs additional metadata related to the library X.
Okay.
Right? So that data comes from my backend. Again,
Okay.
that data is public data only from various vulnerability databases, open source project stats, and all of that. Just that my backend accumulates them and offers it as an API. Right.
Right.
So that backend, yeah, I think it currently handles almost 2 million requests a month.
Wow. So it's quite popular already. I think quite a few people have started using this.
Yeah. I think I don't have any specific telemetry or PII data collection, so I don't know exactly how many people uses it. I get to know when people reach out to me over LinkedIn or Twitter. and tells me that they are using it, they would want a feature, or someone creates a pull request or a GitHub issue telling me that they need this feature. That is how I get to know that how people are using it.
Great, great. All right. Thanks a lot, Abhishek, for your time, and I hope to catch
Thank
up
you.
again.
Sure. Thank you so much. Love the conversation.
Great.